Hi, my name is Alia Patricia binti Ahmad Jais. My number matrix is J25A1780 and this is video for chemistry organic. So in this session, I will explain three main types of organic reaction: addition, substitution and elimination reaction, and then briefly introduce the concept of a reaction mechanism. Firstly, an addition reaction happens when two or more reactions combine to form a single product. This reaction usually occurs in unsaturated hydrocarbons such as alkenes and alkynes because they have double or triple bonds that can be broken and replaced with new atoms. For example, C2H4 plus Br2 equals C2H for Br2. Ethane react with bromine to form 1,2-dibromethane. Here the double bond in ethane break and bromine atoms act across the carbon and carbon bond. Next is the substitution reaction. In this reaction, one atom or group in a molecule is replaced by another atom of group. It often happens in alkenes or aromatic compounds where single bonds are present. For example, CH4 plus Ci2 equals CH3Ci plus HCl. When methane reacts with chlorine under ultraviolet light, one hydrogen atom is replaced by a chlorine atom, producing chloromethane and hydrogen chloride. The third type is the elimination reaction. Here, a small molecule such as water, H2O or hydrogen halide, HS is removed from a large molecule, forming a double bond. For example, C2H5Br equals C2H4 plus HBr. When ethylene bromide is hit with alcoholic potassium hydroxides, it loses HBr and forms ethene. So, elimination is basically the opposite of addition. Finally, let's talk about the reaction mechanism. A reaction mechanism shows how a reaction actually happens step by step, showing which bonds break first and which new bonds are formed. For example, in forming a carbonation intermediate and the bromine. Understanding the mechanism helps chemists explain why certain products form and predict what might happen in the similar reaction. In conclusion, addition combines molecules, substitution replaces atoms, and elimination removes small molecules, and the reaction mechanism explains how this change happens in detail. Thank you.
Hi everyone, my name is Nur Farisa binti Muhammad Damanhuri. My number matrix J25A1723. In this section, I will be explaining about alkenes, which are one of the important groups of hydrocarbon in organic chemistry. First, IUPAC naming rule of alkene. Alkenes are unsaturated hydrocarbon that contain at least one carbon-carbon double bond. When naming alkene according to the AUPAC system, several rules are followed. First, identify the longest and continuous carbon chain that includes the double bond. Replace the suffix N in alkene with "in", number that change from the N nearest to the double bond so that the double bond has the longest possible number. Indicate the position of the double bond in the name. For example, 18CH4 to carbon with one double bond. Basic preparation method. Alkene can be prepared through dehydration of alcohol. In this process, an alcohol is heated with concentrated sulfuric acid H2SO4, which removes a molecule of water to form an alkene. For example, ethanol C2H4 plus H2O. This is one of the simple and most common laboratory method for producing alkene. Key reaction of alkene. Alkene are reactive due to the presence of the double bond. Two important reactions are: first, hydrogenation reaction. Alkene react with hydrogen gas in the presence of a nickel catalyst to form alkene. Second, addition of bromine. Alkene react with bromine water, change its color from orange to colorless. This reaction is used as a chemical test to confirm the presence of a double bond. Real-life application. Alkene have many important applications in industry. For example, it is used to produce polystyrene, a plastic commonly found in packaging material, plastic bag, and bottle. Ethane is also used a plant human to ripen fruit from a quickly. In conclusion, alkenes are a vital class of hydrocarbon that can be easily named using AUPAC rules, separate from alcohol and identified through their characteristics addition reaction, their usefulness in industrial production, especially in making plastic, show how important they are in our daily life.
Hi, my name is Fitri Alia binti Darus. My matrix number is F25A1467, and in this section, I'm going to talk about alkynes. First, I'm going to talk about the nomenclature of alkynes. Alkynes are hydrocarbons that contain a carbon-carbon triple bond. They follow the IUPAC naming system similar to alkenes and alkenes. The suffix Y and E is used to indicate the triple bond. And then, steps to name an alkyne. First, identify the longest carbon chain containing the triple bond. The second one is number the chain so that the triple bond gets the lowest possible locant. The third one is indicate the position of the triple bond. And the last one is name and position any substituents. And then I'm going to talk about the method of preparation. Alkynes can be prepared by dehydrohalogenation of vicinal or geminal dihalides. Treat a dihalide with a strong base such as KOH in alcohol or NaNH2 in liquid ammonia, and then the base removes two molecules of HX, forming a triple bond. For example, dibromoethane, when reacts to alcohol and heat, it will produce ethane. The third one I'm going to talk is about two reactions of alkynes. First one is hydrogenation. Alkynes can be hydrogenated to alkenes or further to alkanes. With linear catalyst, the reaction stops at the cis-alkene stage. The second one is the addition of halogens, which is halogenation. Alkynes react with Br2 or Cl2 to form dihaloalkenes, and further reaction gives tetrahaloalkenes. So the last point I'm going to talk about in this section is the industrial or practical application. The application in alkynes is acetylene in welding. It is the most common alkyne. Acetylene, which is ethane, is widely used in metal cutting and welding. When burned with oxygen, it produces a very hot flame, which is 3000 Celsius, capable of cutting or joining metals. That's all from me. Bye-bye.
Hi everyone, my name is Roslinda binti Ismail and my metric number is J25A1693. In this section, we will be talking about stereochemistry, which is the study of how atoms are arranged in three-dimensional space. First, let's look at two main types of enantiomer. Constitutional enantiomer have the same molecule formula but different atom connection. For example, butane and isobutane both have the formula C4H10 but their structure are difficult. Constitumer, on the other hand, and the same atom connection but different spatial arrangement. Next, let's talk chiral. A molecule is chiral if it cannot be superimposed on its mirror image, just like our left and right hand. A chiral carbon atom is a carbon attached to four different groups. For example, in lactic acid, the middle carbon is a chiral center. Molecules that are non-superposable mirror image of each other are called enantiomer. Enantiomers are interesting because they can rotate plane polarized light. One enantiomer rotates light to the right, while the other rotates it to the left. The property is called optical activity. A good example is D-glucose and L-glucose, which rotate light in opposite direction. Besides enantiomer, we also have diastereomer, which are stereoenantiomer that are not mirror image of each other. Like cis-2-butane and trans-2-butane, most compounds have chiral center but it's optical active because it contains an internal plane of cymery. A racemic mixture contains equal amount of both enantiomers, so the optical effect cancel each other out. Real life application. Stereochemistry is very important in medical and food chemistry. For example, the drug thalidomide has 2 enantiomer, 1 therapeutic and 1 harmful. Also, lemonade acid has 2 enantiomer, 1 smile like orange, the other like lemon. In conclusion, stereochemistry helps us understand how the shape of a molecule affects its chemistry behavior, reaction and effect in real life.